Here's how to build a simple buck converter within 10 minutes. Well, if you already have the components, of course. It's one of the simplest power electronic converters and it's a DC to DC converter. The output voltage of a buck converter is less than or equal to the input voltage, and the required value for an application can be obtained by changing the duty cycle. Say to get 6 volts from a fixed 12 volt power supply, we can use this converter to supply power to the load. In this video, we'll discuss the components needed for building one, test and validate the theory. First, we need an electronic switch to work with. We can use an N-channel power MOSFET as a switch. We also need a diode, inductor, capacitor, and a load resistance. In this video, I've used an inductance of 500 microhenry, capacitance of 10 microfarad, one N4007 diode, and a 100 ohm resistance 5 watt or 10 watt rating. If you connect a regular 0.25 watt 100 ohm resistor, beware, it can burn up emitting smoke. Here's a simple schematic. Here's how the components are connected. I've used a 12 volt input voltage source, and to get the gate to source voltage, I've used an external function generator that produces a square wave with variable duty cycle, say 10% to 90%. The peak voltage of the PWM generator is 10 volts, and it is sufficient to drive this N-channel MOSFET for this simple demo. In a real application, we would use gate drivers to switch the MOSFETs, typically supplying up to 15 volts to turn them on, but that is a discussion for another video. I've used a switching frequency of 8 kHz for this demonstration. As we change the duty cycle from 10% to 90%, the output voltage increases. If I decrease the duty cycle back to 10%, we can see that the output voltage is reduced accordingly. In general, under ideal conditions, the output voltage can be calculated by multiplying the duty cycle with the input voltage. For the next test, let's change the PWM switching frequency from 8 kHz to 1 kHz. Did you notice the change in the output voltage? The output voltage ripple increases and the peak-to-peak value of the output voltage is large for lower switching frequencies. Increasing the switching frequency back to 8 kHz, we can see that the ripple is reduced as expected. There you have it. You have now built a basic buck converter and introduced yourself to the world of power electronics. The world is your oyster. Take care and have fun building circuits. See you in the next video.